Welcome to my talk about using your phone as your backend. I'm Nick Cloward. Some things about me are 15 years of full stack web development, inability to smile correctly in photos, as you can tell right here, strange knack for movie quotes and references, and then I love to meet new people. Let's chat sometime after. So, overview. This is going to be the approach we use at Anonyome Labs for developing, using your phone as your backend. This will go over the high-level overview of the architecture, why, the problems with it, and what the benefits are for it. Let's see. So discuss why would you want your phone or device to be your backend. Mobile devices are everywhere. Well, not everywhere, but most people have them around here in our lives nowadays, so it's readily accessible. Encryption keys, this is a huge point, is that they're stored on the device. This allows you to manage your own encrypted data, even if you send it out in the world. People can't read it unless they have the other side of the key with encryption, which keeps your data, ability to keep users' data on their device. So the database of their data is on their device. They're in charge of it. They can send it out and keep it safe. End-to-end encryption, you encrypt it, send it to who you want. As long as they have the right key, they can decrypt it and see the data. No one else in between can. Low server costs. Since you're leveraging the user's device, you don't have to have a big server farm, and to run, just like we are used to with some web technologies where we have a lot of processing power in the browsers versus a server in the cloud. Some standard reasons that engineers give. Why not? Because we can. And it's awesome. All right, so when I first submitted this talk, I thought, well, what is a backend? So let's define that right now. So I went to the most reputable place and started reading that and realized that it's too long. So I decided to define it myself. This is the definition I came up with, which is the device or application in charge of handling clients' requests for storing and querying data. And I thought, sounds a lot like a librarian. So I threw that up there. And then another thing that kept coming to my mind was, should front end be one word or two? And I've asked plenty of people about this, and I can't get a straight answer, so I left it as I put it in. All right, so the first part here is, this is an overview of the architecture of all the pieces. We have the session provider. Its responsibility is to pair the front end and back end together. And yeah, it's a little, when I was building this, I thought it was a little awkward to see the phone with the text back end. It just doesn't look right compared to, it's backwards. And that's the point of this presentation too. But the session provider is in charge of pairing the front end and back end together and then proxying the data between the two. The back end, mobile phone, which is in charge of storing your data, your encryption keys, and then processing requests and getting giving the data back to the front end, just like a standard web server. The session provider here is front end is the way the user is wanting to access the data. For example, one use case of this is writing emails on your device is not as fun, is not as good user experience, so being able to do that on the front end with the data on your phone. To do this, we're using WebSockets because they provide a dual bidirectional communication. So let's go over the pairing flow here. The front end initiates a connection with the session provider. The session provider says, okay, here's a unique binding token, and sends it back to the front end. The front end will now display that binding token as a QR code. This is kind of where it meets up, and we can pair the front end to the back end by giving the token to the back end by scanning the QR code with your back end, which is your device. The backend now initiates a new connection to the session provider. It then sends up that binding token it got from the QR code. The session provider uses the binding token from the backend, creates a new session object, and then you can see the session data here is an example of what it could be. Session ID, unique ID for the session, a binding token that was passed through, some sort of identifier for that WebSocket connection for front end and back end, and then an expiration timestamp when the session is over, has expired. Session provider. Again, binds the back end and front end together with the session. And, okay, let's look at the data flow. It's bidirectional. So let's start with our front end to back end. The front end sends requests for data. Need more input. We got Johnny 5 short circuit thing there. Proxies request. The session service proxies a request to the back end via the binding token and that session, so it knows which ones are connected. The back end now processes that request, uses the encryption keys that are on the device to decrypt that data while it's processing the request. And once it's done, sends the requested data, more input, backed up to the session provider. Session provider forwards it back on to the front end. Now, let me expand on this a little bit. This is encrypted data too, so using HTTP, WebSockets, WSS. Front end consumes the data and displays it to the user. So we went from a standard web request, which is requesting data and back. Now let's look through back end to front end. So let's say you have an external service. Maybe you receive an email. That email comes in from your service, maybe as a push notification, whatever, to the back end device. The back end device gets that, sends a new input up to the session provider, sends a new input down to the front end, and the front end consumes that data. This is not a warning, it's supposed to be a notification. like a push notification. You have a new email. You've got mail. All right. So that's the basic part of the architecture. Let's go into, we can expand on this a bit more and make it more smarter. So we can use this by using WebRTC. So what is WebRTC? WebRTC was developed by Google. It allows, in my simple terms, it allows the device, the front end and back end, to talk to each other directly. It knows how to go through the maze and pipes of the internet to talk to each other. It does this first by the same as before, is pairing together. But WebRTC, as you can see here, they can connect directly. And then we can close off that connection. Now, if it fails, we can fall back to the old, or the original. So what are the problems with this? There are many problems, but let's go over some of the major ones here. Slower, unstable connections. Mobile devices, they move, they have different connections, they're wireless. You go in a parking garage, it can't connect, which means your connection is down. So the health of the connection is extremely important. Device hardware limitations, they're not all the same. They have different processors, RAM, you name it. So that's a downside. Keeping that running on the device. This is a big one that we've had some problems with, because it's a bit easier on Android, but on iOS, they're very picky about what the apps can do while they're running in the background, while the user's not actually interacting with the app. In one way around this is to use white pushes, which is normally used for when the app receives, say, a phone call, if the app supports that. When it does this, we can do that by keeping it open, by pushing the data down, and it keeps the app open. However, since this has been, in my mind, abused, which is a good thing, in iOS 13, they are locking this down so it won't happen anymore, which means you basically have to keep the app open yourself, which kind of sucks, but it's a good thing because it locks down other apps from tracking data and staying open when you don't want it to, and tracking data you don't want it to. Some data needs to be available. For example, email address. If all the data is encrypted, we don't know where to send the email to. So some of the data, like the email address to and from, and metadata about it, needs to be exposed. It can't be encrypted completely. Slower release process. You're deploying to devices, going through the flow of app stores and whatnot. Whereas like, I come from web mostly. You have your server, you can quickly deploy to that. It's really quick. Slower processing, it's slow with certain devices, device limitations. Single place of failure. You lose your phone, your data's gone, your keys are gone. It's gone. There are ways around some of these, like backing it up, and it's really complicated. A lot more complicated than just a request up to a server and back. You have a lot more moving parts, so it requires a lot more knowledge of what's going on, and debugging is a little more difficult. So let me get back to, again, why. Why would you want to do this? Well, the benefits for us are privacy, keeping the data where the user has access to it and not allowing people to see your data. I work for Anonyome Labs. We do privacy and virtual identity software. And so to us, it makes a big deal to have an architecture like this and go through the pains and the benefits to providing that to customers. So I'll put a plug in here for my sudo. And I was going to do a demo, but I don't know if I'd have enough time. So I'll put this plug in here. You can go download the app on an iOS device, Android, I don't know, I'm not product. But it allows you to use this same technology to write emails and send messages through your phone with encrypted data. My last thoughts are, so I want to invite you to think about the data you're using and what data you're collecting and what you're doing with it. And do you really need it? A lot of times when I've built apps myself, it's been, oh, let's get all the data we can, let's store it, encryption, what's that, security, well, that's not a big deal right now. So just be mindful of what data you're storing and you're using when you're building your apps, and then, questions? How are we on time? 5-10 minutes already? That went a lot faster than my test runs. In that case, let's see if we can either have a disaster or a demo. I can also go into a few more slides that I hid because I didn't know if timing would be right. Okay, see that okay? There we go. So you can't see my phone, but I'm coming into the app here, and I really wanted to try this. There we go. There is my data going through a proxy to my phone. If I put my phone in airplane mode, I can refresh here. And it's done. There goes, lost connection. So you can see how like the connection issues could be a big deal, and which they are. We've spent a lot of time working on problems as far as backing up your data, backing up your keys, a lot of work and time on keeping connection reliable, and the more data you have, and those pipes, those WebSocket pipes, change all the time with your device. So you could have a lot of data going through it, and it's just, the pipe's just not big enough. So, alrighty. All right, so let me unhide this here. Maybe. All right. So a little bit more into this is WebRTC. We can leverage WebRTC to help this out a bit, this architecture. WebRTC, if you don't know what it is it was developed by Google, and it allows a way to navigate the pipes of the internet to connect your phone directly to your device, so you don't need the session provider up above. In a happy path case, You probably used it a lot when you use Hangouts. Zoom probably uses it, or a lot of these video-to-video calls to help with routing data. So the WebRTC can allow you to just take the session providers there to link everything up, but once it's up, it's connecting directly. When WebRTC fails, it does go back, falls back to the WebSockets proxy. And any questions?